solve x minus 1 over x is greater than or equal to 0. This is a rational inequality. There are two types of numbers that we look at to break a number line into intervals. The first one is where it's undefined. This is undefined when x is 0. So x equals 0 will be one point that we will want to use to divide this number line into intervals. The second type we look at is where the related equation is true. In other words, what values of x will make this true? Well, if we solve, we multiply everything by x, we get x squared minus 1 equals x times 0, which is 0. Factoring, we have x plus 1 times x minus 1 equals 0. If x plus 1 is 0, x equals negative 1. And if x minus 1 is 0, x equals 1. So really, from here, we have two x values. And from our discussion up at the top, we have one x value. So this number line is broken into three intervals by the negative 1, the 0, and the 1. And we can label these intervals if we want, A, B, C, and D. Now, under each of these, we want to find out whether x minus 1 over x is greater than or equal to 0 is true in each interval. So let's start with interval A, and we pick an x value in here. Let's just try x equals negative 4. Then we ask ourselves, is x minus 1 over x greater than or equal to 0? That would be, is negative 4 minus 1 over negative 4 greater than or equal to 0? That's a question we're asking ourselves, okay? Put that a question mark there. Well, negative 4 minus 1 over negative 4 is negative 15/4. Is that greater than or equal to 0? Well, no, it's not. So this interval will not be part of our solution set. Let's try this one, and let's pick a number between negative 1 and 0, and it has to be a fraction. Let's try negative 1/2. X minus 1 over x will be negative 1/2 minus 1 over negative 1/2. Is that greater than or equal to 0? Well, if we simplify here, we get 3/2. Is that greater than or equal to 0? Yes, it is. So interval B will be part of our solution set. Let's try the same thing for C. We'll try positive 1/2. Again, we ask ourselves, is 1/2, let's draw a line here so we can see there. Is 1/2 minus 1 over 1/2 greater than or equal to 0? We have negative 3/2 greater than or equal to 0. That's not true. So that's not part of our solution set. For the last interval, D, I'll move down the page. We want to pick a number greater than 1. So let's try 3. This is interval D we're working on here. We would have 3 minus 1 over 3. That's x minus 1 over x. Is that greater than or equal to 0? If we simplify, we get 8/3. Is that greater than or equal to 0? Yes, it is. So interval B and interval D both make that inequality true. Now, the only last thing we have to determine is whether we include the endpoints. We do not include 0 because that endpoint makes the expression undefined. Because the inequality symbol is greater than or equal to, we do include the negative 1 and the 1. So we want these two intervals. We want interval B, which is negative 1 to 0, but not including 0. And we want interval D, which is 1 to infinity. That's the solution set, or we can write it as the set of all x such that x is between negative 1, including negative 1, and 0, or x is greater than or equal to 1.